Welcome back to my channel. Today we are going to learn about a very important concept in organic chemistry, that is structural isomers. Structural isomers. Okay. So now first we will understand the definition of structural isomer and then we will see the example. It is a very important topic from the exam point of view because generally they ask question from here. So what is structural isomer? Compounds, or we can say organic compound having same molecular formula, but different structure, are called structural isomers. Okay. Now, so what does it mean? It means that the compound will have molecular formula same, but the structure will be different. Okay. So the isomers are what? They will have the same molecular formula, but the structure will be different. For example, suppose we say butene. Okay, we know from our previous class, butene is an alkene with carbon 4 because it is but, and hydrogen just double of carbon, that is 8 because it is ene, it is alkene. So this is the molecular formula of butene which we know from our previous knowledge. Now you see this butene structure we will draw. Okay. So there are two ways by which butene can be drawn. Earlier in my class we have already learned how to draw the structure of alkene. So butene, 4 carbon, 1, 2, 3 and 4 carbon. Okay. Now first we will make all the carbons single bond, and then first and second carbon we will put double bond because it is alkene, and then rest we will satisfy with the hydrogen. So 1, 2, 3, 4, 5, 6, 7 and 8 hydrogen. Okay, so this is the structure of butene we have already studied in my class where I taught you how to draw the alkene structure. Now, what is the other way by which we can draw butene? So it is see 1, 2, 3 and 4. First we will make it single bond. Then instead of first and second carbon, we will bond second and third carbon with a double bond. Okay, and now we will satisfy. Okay, so it will be like this, and we will satisfy all the bond with the hydrogen. 4, 5, 1, 2, 3. Yes, this was wrong. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7 and 8. So what we did? Instead of bonding between first and second carbon, we bonded second and third carbon. So this is the another structure of butene. Okay. They are totally different from one another. These butenes are different from one another because the double bond position is changed. So the name will also change. This butene will be called but-1-ene. Okay. Now this 1 stands for this carbon number 1. That means this indicates that the double bond is present between first and second carbon. Okay. So since we are indicating the carbon number here, the double bond is present in second and third carbon. So we will name it but-2-ene. Okay. And this but-1-ene and but-2-ene are isomers of each other. What are they? They are isomers of each other. Now you see, this is satisfying our definition. Okay, definition says same molecular formula. Yes, they both have the molecular formula C4H8, but different structure. And you see the structure, how it is different, because in this butene the double bond is present between first and second carbon, and in this butene the double bond is present between second and third carbon. So this is the isomer of butene. Now one more example. Okay, now before going to the second example, I just want to teach you one thing. You can ask if but 3-ene is also possible if the carbon double bond is present between third and fourth carbon. No, but 3-ene is not possible, because there is one law of naming organic compound. Okay, so you should know this law of naming organic compound. Naming organic compound, which says okay, according to this law, carbon is numbered from where the functional group is nearest, Okay, what does it means? Okay, in this icon, okay, so you see this, according to this law, if you will draw this structure showing carbon 1, 2, 3 and 4 and double bond between third and fourth carbon. So that according to this structure, the name of the compound should be but-3-ene. But this is not correct. Why? Because our law said numbering of carbon will be done from where the functional group is nearest. And we know in alkene double bond is the functional group. So we can't number this carbon as 1. We have to number this carbon as 1 because functional group is nearest from this carbon. So the name of this compound will again be but-1-ene, not but-3-ene. Okay, so while naming the organic compound, we must know this law. Okay, one more example, then it will be more clear. Okay, like suppose butanol. Okay, butanol is an alcohol with 4 carbon. Okay, so butanol is what? It is an alcohol with 4 carbon. So its formula will be C4H9OH. Okay, same like alkene, we can draw 2 structure of butanol. Okay, now you see this. 1, 2, 3, 4 carbon, okay, with 9 hydrogen, H, and 1 OH. Okay, 9 hydrogen and 1 OH. From the above example, butene, you know that what I will do, only I will change the position of OH. So the second structure of butanol is 4 carbon with 9 H and 1 OH. Okay, so you see, but only I change the position of OH from here to here, Okay, and this name again, the name of this compound will be butane 1-ol, and this will be butane 2-ol. Butane 3 and butane 4-ol is not possible because again the carbon numbering will be start from the side where from where the functional group is nearest. So suppose if I attach OH here, this carbon will become 1. So we can't name it as butane 4-ol. And if I will attach OH here, it will become the second carbon, because from here OH is nearest. So it will again become butane 2-ol, not butane 3-ol.